Okay, today we're going to look at bone function, so the jobs, the functions of the bone, and then we'll look at organization a little bit. So one of the main things, support and protection. Bones give shape to things, so your face, your head, your arms, they're going to give the shape to whatever covers it. So obviously your face has a different type of bone than your arms do. So they give shape to your body, basically. Pelvis and lower limbs provide support for your body's weight because of the way that when we walk on two legs, our hips have to be proportional so that we can provide support for the weight of our bodies. Bones of the skull, protection, protect the eyes, ears, the brain. Obviously the brain is very important, and your skull is pretty thick, so gives very good protection to the brain. Rib cage, shoulder girdle, also protection. Vital organs, your heart and lungs are very well protected. Pelvic girdle is going to give some protection to your lower abdominal and reproductive organs. Your abdominal area is a little bit less protected as it kind of sits in front of your pelvic girdle, but your heart and your lungs are protected very well by bones. So support and protection. Body movement, your bones act as levers, like in physical science. We'll look at a picture of that in a little bit. So a lever itself has a bar, a fulcrum, the object that is moved against resistance, and then your force. So your force end and your resistance end is the way you probably heard about it in physical science. In the skeletal system, the bone is the bar. It's the actual lever part. The joint is going to be the fulcrum, and the fulcrum is the part that allows movement. The object being moved is the resistance, and then the force comes from your muscle being contracted. So body movement, very important part. So here, if I am looking at my arm as my bar, so my whole arm is my bar, the fulcrum is the joint. The fulcrum is the part that allows movement. So your joints are the only places that allow movement. I cannot move my arm in the middle of a bone. I can only move where there is a joint. Resistance is going to be the part that you're moving. So if I'm picking up an eraser, that's going to be my resistance. And then my force is going to come from a muscle. So your muscles attach to your bones. So obviously when my bicep contracts, it lifts the front part of my arm. So obviously this muscle has to be attached up here somewhere because it's pulling this bone forward. So your bones are very responsible for movement. But the part of your bones, or not even the part of the bones, the responsible part of that action is your muscles that are connected to the bones. So your muscles are what cause your bones to actually move. Blood cell formation. Blood cells, the process of blood cells forming is called hematopoiesis. And that's basically just forming new blood cells. They're later manufactured in the liver, the spleen, and then they finally form in bone marrow. So hematopoiesis actually starts in a yolk sac. They go to the liver and spleen, but their final formation ends up occurring in the bone marrow. What I want you to know out of this part is that your bone marrow is responsible for producing blood cells. So it is the bone marrow that helps with that. There's two kinds of marrows that fill the medullary cavity and larger canals in the bone. Red marrow is going to fill spongy bone. So your spongy bone, remember the ends of your bones. We looked at the inside of a rib, has spongy bone, skull, clavicles, vertebrae. Anywhere that you have spongy bone, it's going to have red marrow. Red marrow forms red blood cells, white blood cells, and platelets. The color, the red color of red marrow comes from hemoglobin, and that's where your red blood comes from. Blood carries hemoglobin, which is responsible for transporting oxygen, and that hemoglobin has a red pigment. So hemoglobin gives your blood red color, and it also gives red marrow its red color. Spongy bone, red marrow. Yellow marrow stores fat, and it has a yellow to whitish color, and it is going to occupy cavities, including your medullary cavity. So inside the center of your long bones is where most of your yellow marrow is going to be found. And its job is to store fat. Inorganic salts or storage, the matrix, the extracellular, so outside of the bone cells. This matrix of bone is full of calcium salts. So when we talk about your body needing calcium or your bones needing calcium, this calcium is turned into salts such as there's calcium phosphate, there are calcium chlorides. So these calcium salts are important for metabolic processes that take place in your body and in your bones. So the calcium in bone is a reservoir, so it's going to store extra calcium or body calcium, so that when your blood levels, if your blood levels are low on calcium, osteoclasts, clasts break down, osteoclasts are going to break down this little portion of bone. It's going to release the calcium, and then it can be released into your blood. Your parathyroid, your thyroid and parathyroid are very important for metabolism. And your parathyroid gland releases a hormone that basically regulates your calcium levels in your blood. Calcium is also stored under the level of calcitonin, which is used when blood levels of calcium are too high. So prior slide, we talked about if you have a low level of calcium, osteoclasts are going to break down so calcium can be released. The opposite, if you have too much calcium, calcitonin is going to store the calcium. Besides calcium, bones store magnesium, sodium, potassium, carbonate, all of these ions that can make salts. So I can have a magnesium carbonate salt. I can have sodium phosphates. So your bones are going to store a lot of different salts. Side note, they can also accumulate harmful metals like lead, lead-based paint, no longer used, lead shot. If you shoot pheasants, you might use lead shot. Radium, strontium. These harmful metals actually, they're absorbed by your bones, and then they accumulate in your bones. So too much of these metals are not good for your body. Here we're going to look at calcium levels. So here's an example of homeostasis with your calcium levels. There is a normal blood level. If for some reason my calcium gets too high, it's going to, my blood calcium level increases, my thyroid decides that, and calcitonin is released. Calcitonin is going to cause osteoblasts to put calcium into the bones where it'll be stored. And then it's going to return to normal. Opposite, my calcium level's too low, it's going to sense it's too low. Parathyroid is going to release parathyroid hormone. Osteoclasts are going to break down bone. Calcium's going to be released. What I want you to take out of this is too much calcium. Calcitonin is responsible. Osteoblasts break down calcium. Too little calcium, my parathyroid is going to cause osteoclasts to release calcium. So I am going to stay at that normal level of calcium. And I'll stop there quickly.